Okay, I welcome you all for faculty development program of AICTE, HIT, Idea Lab. So the theme of this faculty development program is based on fundamental principles of micro and nano technologies. We have with us Professor Dr. Tarun Gandhi Jana. He is the Dean, School of Engineering of our institute. And we are very fortunate to have with us Professor Dr. Sandeep Sarkar. He is an eminent personality from Jadavpur University in the Department of Mechanical Engineering. So I would now like to request Professor Tarun Gandhi Jana sir to say a few words for this inaugural session of this evening.
Good afternoon. Welcome to this inaugural session of FDP on AICTE Idea Lab, having the topics micro and nano technologies. Perhaps all of you are aware that our AICTE Idea Lab HIT was developed in mid-April of 2022. Since then, a good number of FDPs and student orientation and grooming program had already been organized by this AICTE Idea Lab. This Idea Lab is basically a conglomeration of different disciplines such as mechanical, instrumentation, electrical and electronics. But that does not necessarily mean that IT competition, those people cannot participate in this venture. The main theme is basically the skill development using the latest technology and idea materialization. So the different state-of-the-art fabrication and other machines the resources are available that could be utilized for quick or rapid product development. In the current days, innovative thinking, new ideas play a very crucial role for the business sustenance. And in that perspective, simple thinking or analytical work is not sufficient. We have to realize the product so that quick transformation from the conceptualization to the realization by using state-of-the-art facilities such as 3D printing, laser cutting, PCB fabrication. These sort of equipments can help immensely to realize our concept or our ideas into a reality. This time the topic that has been chosen, that is the micro and nano technologies, these are also playing very crucial role in the current days. In one hand we had the tremendous development of IT communication sector, and at the same time miniaturization of the products that also is very much demanding. Once the product becomes smaller, lot of problems can be eliminated. Heat generation, space, material savings, these are also very critical. One example I can tell you, those who are having cars will find that majority of the cars employ 3-cylinder engines. Although 4-cylinder traditional engines have got certain advantage in terms of smooth running, reduced force and vibration, but still why people are going for 3-cylinder engines? The major objective is that to reduce the material cost and reduce the space. So this philosophy is equally important in other areas as well. Whether, so that we can think about very small items. So that gives the tremendous potential and the development leads to the emergence of electromechanical system or even nano electromechanical systems. Even flow phenomena or heat transfer phenomena through micro channels, those are also gaining importance in the current days. So with these words and with this particular theme, I think this particular topic that has been chosen for the discussion, particularly for this time, would be of immense help for discussion as well as for your idea materialization in this FDP program. So I wish all people who are to be undergoing this 1 week FDP program by using our HIT AICT Idea Lab will be of immense help, and it will be of course interesting, and I believe that you would be able to come up with some new idea, and it's very relevant. I wish all success to this particular program. Thank you.
Thank you, sir, for your encouraging thoughts on this program. Now, I'd like to request Professor Dr. Sandeep Sarkar, sir, for delivering his thoughts.
Introduction to this AICT sponsored idea generation laboratory on macro and nanotechnologies has already been explained by Professor Bose and Dean of Engineering. So macro and nanotechnology has got immense potential not only from the academic perspective or from the generalized perspective to academic research, but it has got immense potential in biomedical, industrial application in the development of smart sensor actuators. Nowadays, one of the important consideration in macro-channel research and macro-channel application is basically its optimization. So with a very small volume of fluid, small volume of area, we can get very optimization in heat transfer, optimization in fluid flow, which may be helpful in in fluid diagnosis, large sample collection and research, and also early detection of diseases. So from that perspective, it has got immense potential not only through experimentation, but by applying very simple concepts, simple theoretical knowledge, you can get a lot of information for macro-channel flow and macro flow characteristics. So that may be helpful for industrial applications and maybe high performance. Maybe when we talk about the macro-channel flow, we generally consider biomedical applications, biomedical, biochemical applications. Not only that, because macro-channel flows can also be applied, or it is very much applied for high-speed computations. High-speed computation for where you can require rapid cooling, in-situ cooling of the electrolyte components. So in this idea generation lab, so where you can interact with your peers, you can interact with your faculty members, you can get a lot of information and you can exchange your ideas so that certain things can grow up, certain new things can come up which can be directly implemented for the generation of new devices that may have immense potential in biomedical research, industrial research, smart sensor development, and so on and so forth. So with this short introduction, I welcome you in this session. Hopefully, this session will be very much useful and very much knowledgeable experience for all. Thank you.
Thank you, sir, for sharing your wonderful thoughts. So, as you know, as my expert and Professor Jana has deliberated that micro and nanotechnology is being widely used nowadays in micro-mechanical electrical systems or machines or components. So miniaturization of the components in electromechanical system is the need of the hour. Like you find the smartphone, you find the devices for detecting the health of a human. So all these equipment, that means biosensors. Nowadays biosensors are being widely used for detecting the health condition of any human. Now it is so that in near future, like this Android phone will be abolished. So research is going on in this area where biosensors can be modified into Android phone. So it is somewhat like a holographic image which will be developed on the palm or on the hand with the help of this biosensor. And with that we can operate this Android phone. Maybe in 5 to 6 years down the line, this will be coming because the research is going on a very fast rate. Okay, so and see nowadays we have those smartphones which are monitoring our health condition. That is also with the help of biosensors. So in this area, this biomedical engineering with the help of nanotechnology is moving at a very fast rate. So and we are having some of the components and some of the equipment which are commercially available in the market. Now another aspect of this nanotechnology is that the 3D printing. So this 3D printing is basically a nano level deposition which is taking place in layered formation for developing prototypes. Okay. So these are the areas rightly in the domain that is coming up at a very fast rate, and these are getting developed very fast. So in the new generation that will be having the exposure of this nano technology along with this sensors and all, even if in the embedded system also you will find this nanotechnology is being widely used. Right. Now in mechanical, personally I can say that in the domain of manufacturing also, we thought of like a few years back in the scale of nano machining or micro machining. Now the work is being done at the femto level. Okay, forget about pico, it's at the femto level. Femto level is so minute, the diameter is half of our hair. Okay, that is what the practical example of femto, half the diameter of hair. At that level, machining is being done. So see how the technology has progressed in this area. So this is a very emerging area. I hope people who are working in it will be helpful in this regard. So now I will thank all the participants for joining this FDP. I will thank our institution for helping us in all the logistic supports. I will thank AICTE for providing us this opportunity to develop this idea lab and to give the exposure to the new generation faculty members. So all in all, I thank you all. Thank you, Professor Jana, Professor Sundip Sarkar, for giving their valuable time for this inaugural session of this MDP. Thank you once again. Now we will be moving to Idea Lab right now. Professor Dipendu Chaudhary is waiting there in the Embedded Systems Lab. So the participants will be joining for the hands-on experience in the Embedded Lab of Idea Lab. Okay, thank you very much.